So I got another project from my brother-in-law. This one is a fishing lure, and it's a fishing lure designed to catch halibut. And he founded a company in Alaska. It's called the HaliBut cracker to catch halibut. And it involves two pieces of stainless steel and a stainless steel shaft with some E-clips to hold them in place and a spring in between. I'm going to use this material that I've got here. This is 304 stainless, which is 18/8. Not ideal for salt water, but I couldn't get any 316 locally, and less than long lengths, and stuff's very expensive. So we're going to see how the 304 survives the salt water. And also it's the short end, which was scrap. It's too large in diameter, so I got to turn it down, and I need about 2 inches of the 3 inches. So that presents a problem, and I have a solution for that. What I'm going to do is I'm going to face this, and then I am going to thread one side, and I'm going to thread an arbor, and I'm going to screw it on the arbor and then turn it that way. So we'll get started with that first. So I faced the stock both sides, and now I'm just going to drill and tap for 1/2 inch 13. So switch to load here, and just going to do a center drill. Okay. So I zeroed my DRO. We're going to go in 550 thousandths. So my tap chart has soft metal and hard metal sizes for tap drills. So I chose one in between because I think this stainless is somewhere towards the hard but not hard. So I'm going to go right in the middle. So just tapping for 1/2 inch 13. So I've switched to a bottoming tap to get as many threads as possible. I only went in about 1/2 inch because I'm trying to minimize material waste. So I just want to get as many threads as I possibly can. So what I did was cut out a piece of all thread, and this is the stock that I need to use the most of, so I'm going to run the thread in all the way to the bottom on that guy, and then tighten it up on this guy. I left these edges really flat so they're sharp. Okay. So now I'm going to load this guy up in the chuck and turn this guy. And you may wonder, do you have to worry about it loosening? But fortunately, when you're turning in a normal direction this way, the cutter is going to force this to tighten on the arbor. So we should be good to go. So we'll be ready. Let's turn this down to the 1.5 inch nominal diameter I need and make my couple pieces. So before we remove material, because there's so much stick out here, we're going to pre-drill this for the full little bit over 5/16. Actually, I think we're just going to go for 5/16 right now, which is the rod that's going to go down the center of the two pieces. So we're going to drill all the way down 2.5 inches. Then what we're going to do is we're going to stick the center in the end here to help support this before we reduce this diameter down 300 and something thousandths because it's over. So we're going to start with the center drill. Then we're going to drill with, this is like a 3/16, and then we're going to work up to the 5/16 and test the rod, see how much slop we have. We want we want a fair amount of slop on this, so we're going to play it by ear and see how it feels. The drill bit we're using was a DeWalt cheapo. We weren't getting symmetrical chips out of both flutes, so I swapped to a cobalt bit that I had that was better. Much better. So the lure itself needs a fair amount of slop because they're counting on the noise of the stainless steel bits moving on the shaft to make noise. So we overcut it by a full 32nd, and so there's the slop you get, which is what we want. So we're gonna have two 1-inch pieces, and they're gonna slap around on here. Here is the original right here, and you can see there is a huge amount of play because they're counting on the noise of this attracting the fish. So we're trying to duplicate this. So next stage, we got to take this guy down from the 1 7/8 or the 1.875 inches down to about 1.5 inches. And again, dimension's not critical. We just want it about 1.5 inches. Obviously, they chose the size probably on availability more than what the fish's mouth size is, but that's what we're going for. So I've got the feed rate pretty high. Currently the feed rate is at 14 thousandths a revolution. So what we're going to be doing is I'm going to be taking 25 thousandths bite at a really high feed rate. So here's the first one we're going to see if we can do this without lube, see what happens. And 440 RPM right now. This is going to be quite a few passes. Here's another perspective, also almost 15 thousandths a revolution. Chip breaker is still not engaging. So maybe next pass we will shoot for 35 thousandths depth of cut and see how that works out. All right, it's 35 thousandths depth of cut, closer shot. Still no chip breaker properly engaged. Alright, so let's try 40 thousandths. Or let's go for a higher feed rate still. Something higher than I've ever done before. Let's see. So we've decreased our cut back down to 30 thousandths, and our feed rate has gone from 14 thousandths a revolution to 22 thousandths a revolution. Let's see how it does. Last pass, 5 thousandths, 2.2 thousandths per revolution. In case you forgot, 304 stainless. I'm going to round over this far side here. I got a 1/4 inch round over bit. We'll use some lube. Problem is, this is tight in here, getting some chips stuck. We'll finish it up with some sandpaper and clean up the edge. Yikes! Definitely some chatter marks. So the first piece here is mostly done. Now we're just going to part off a 1-inch section of this guy. And we'll have to do one other turning operation on the inside of it to relieve it for the spring later. But we're going to part off 1 inch. I've slowed it way down. I'm going to start off without using power feed and just see how this works. So we're going to relieve this side. We're going to go in 1/4 of an inch. And I've got a 1/2 inch end mill in here. Carbide. We're going pretty slow. Now we're going to part off the second piece, then we can turn it around and relieve its inside like this. So here's what's left over of that piece of stainless, and we just unscrew it. If you want, toss it in the trash. What? That's it. So we were able to utilize a lot more. If I only had this much in the jaw, never would have been able to hold it safely. So that was my trick. So I'm just going to take a really light facing cut now and just clean up the face. Then I'm going to chamfer, and then I'm going to put in the 1/2 inch relief. Got the RPMs up to 680. And we're really taking a very light cut, just cleaning it up. All right. Now we can chamfer the outside edge. This is razor sharp. And we can relieve the center. Second part finishing. First I'm going to take a little facing cut after I get it out of neutral. I had to dial in the forejaw, so I put it in neutral to do that. Second part, quick facing. I'm going to chamfer the corners, relieve the center. Chamfered the outside. All right, and we're going to do a 1/4 inch. Being a fishing lure, it must be precise. I think it's been said that fish can tell the lousy machining job from a long way away. Alrighty. Second part done. Now we just have to do the shaft. So working on the shaft, it's got a ride on. We're gonna first face it off. And I'm gonna chamfer. And now I'm going to pull out some more stock, and then we got to cut some grooves for the E-clips. Okay, so here we are. We're going to do the grooving. I've got a micro 100 carbide bar for grooving. Fantastic finish on this thing. I bought it off of eBay. Someone was selling it. Great deal, brand new. So we got to go backwards because I'm on the rear side of this guy. And let's just cut this. So we got to go 93,000. I mentioned it's cutting like butter, even the stainless. We had to switch to a different setup to groove the other side. This time the lathe will go in the normal direction. Looks like with this one, might need a little lube. So here we're going to machine flats into either side, on both sides of this, and then drill a hole down the center for the ring clip. Get the speed up to like 25,000 passes. Let me just loosen this guy. I don't know if you can see that, but we just loosen this guy, flip it over 180, pop it back into the stop I left. Rinse and repeat, and I did set my x-axis to 0 so I can come back to the exact same spot again. Alright, so here for the final assembly, you got to purchase one of these silicone squid skirt deals. And this is the top part that's a swivel. With 2 split rings on either side. So here's the assembly order. Actually, we've got to put the split ring on the bottom with the hook. Then this thing slides over that whole bit. Then you put a E-clip on, and then the 2 center pieces with the spring inside, another E-clip, another split ring, and the swivel. The split rings are really heavy duty, so I'm going to try and do this off camera. I'll bring you right back after we got it assembled. So here's the first stop. We got the hook and the circlip on the split ring clip, and it took 2 of us to do this. It's so heavy duty, we're going to have a hard press to do it by yourself. So next goes on the squid bit. We'll put that on, bring you back. So this squid draping thing is actually 2 parts. So the internal part we zip tied in place just under where the E-clip goes, then slid the top one down over it. Now we put on the back piece and the spring that we cut based on tension, and the top piece, and there are tools for putting on these E-clips, but now we're going to put the last ring on swivel. We'll do that off camera again because it takes 2 people. So here's the whole lure together. It's to catch halibut, and it's designed to make a lot of noise that attracts the fish. Again, we put this over the hook because we kept finding the sharp point. Alright, so that's it. Thanks for watching. Hope to see you next time. Hope it was useful.